Hello, well, this one is to do with proportion. Let's get let's use a better pen than that, proportion. Right, so basically there are two types of proportion. There is direct and inverse. Direct and inverse. Okay, now the direct proportion is where when one thing goes up, so does another. Right, and let's have a look at an example of this. Say we're buying a quantity of something, so we can buy one, and then we've got the cost per item, and we call that £1. Then we'll have the total, and that will be £1. Yeah. Now, if we're going to buy 5 of them, the cost remains at £1. So the total goes up to £5. If we buy 10 of them at £1, then the total is going to be £10. Yeah. So we have a direct proportion between the quantity we buy and the total amount that we have to pay. So as one goes up, the quantity goes up, the total also goes up. And we can have, this could be Y, this could be X, it doesn't really matter which way round it is, and the cost has to remain constant, and that we call a K. So we can have a formula for this would be Y equals, let's do it the other way around. Let's have X before Y, so that we're working backwards on the thing. So this will be X and this will be Y. So Y, the total cost, equals the constant times the number that we buy. Right, inverse, the other way around. So we have to remember these little formulas, or any way around. X equals ky if it's all reversed and backwards and forwards. So this time we'll have the quantity, and again the price per item, and then the total cost. Now this time the total cost has to remain the same. This is the constant, and we'll call it £100. So if we buy one of them, the price per item has to be £100. If we buy 2 of them, then they'll have to be £50 each, so that the total cost remains £100. If we buy 10 of them, then this has to be £10, and there's £100 as well. So you can see, as the quantity goes up, the price per item has to come down so that the total is always the same. And this makes the total the constant this time, and we'll have X and Y around this way. Yeah. So we can have a formula for this, that the X times the Y is always equal to the constant. Okay, so this can be written several different ways. You could have Y equals K over X, or even Y equals 1 over X, just to show you that it's the inverse makes it the inverse proportion, so as one goes up the other one goes down. So this is really the one you need to remember. The first type of question that you're going to get on proportions might be similar to this. So you get a little table here, and we'll have an X and a Y, and there'll be some missing bits that we have to fill in here. We call this 10. and we call this 20. Okay, so we could say x is directly proportional to y. Yeah. Now, directly proportional is, as we did in the first little bit, we need to remember that y equals kx. And if we jiggle that around, we could not need to find the constant. Always need to find the constant first. So we go y over x equals the constant. And we'll fill one of them in because we don't know the y and the x yet. So let's fill that one in as, say, 10. And then we've got two missing bits. So 10 divided by 10 equals 1. So the constant equals 1. So here we've got, now we can go back to this y equals k times x because we need to find the y. So that equals 1 times 5, which equals 5. Yeah. And if we do it the other way around, x equals k divided by y. X equals, it's y divided by k, sorry. What a mistake. Y divided by k. Now y is 20, k is 1, so that equals 20. And you can see it all works out the same. It all works out the same. So you've got to use this direct proportion formula and a lot of moving around, yeah, juggling around. Y equals something, x equals something, k equals something. So that's how to do a direct proportion. Now I guess that I'll have to do another one for the inverse proportion. And so we say x is inversely proportional to y. Okay, so do this, and again we're going to have x there, y there, and let's fill some in. Let's fill some in. So we'll have 20 and 20, 60, and we'll have 10. So we've got to find one y and one x. So first of all, let's have the inverse proportional, which is x, y equals k. Find the constant. Here we go. This one is 20 times 20 equals 400. So k equals 400. Okay. This one we have to find y, and we're going to use y equals k divided by x, which equals 400 divided by 10, which equals 40. So we can stick that in there. This time we've got to find x, so x equals k divided by y. So again, 400 divided by y, which is 60, and that equals 6.67. It's 6 recurring, but that would do. So you can go 6.67. Odd numbers, but yeah, so there you go. So you can get those sort of tables where you have to fill in the missing x's and y's, and always remember these formula and the one for direct, and you'll be fine. Yeah, you've just got to rearrange these little equations, but there's only 3 letters there, so that shouldn't be too much of a problem. Right, now what's the other sort of questions we can get? So you can get wordy questions. Yeah, Hannah pays £3.60 for 400 grams of cheese. Okay. She uses 220 grams to make 4 pasties. How much would it cost to make 50 pasties? So this is direct proportion, isn't it? Because the more pasties you make, the more cheese you use. The more cheese you use, the higher the cost. So, first of all, we're going to find out what the relationship between the 4 pasties and the 50 pasties are. So, 50 divided by 4 is 12.5. So, from 4 pasties, we're going to make 12.5 times more to make 50 pasties. So we need to do the grams of cheese. So we got 220 grams times 12.5, because that's a scale up, and that's 2,750 grams of cheese. Now, we know that it's £3.60 for 400. So what we're going to do is just find out what it is for 1 gram, really. So I suppose we'll change it into pence. 360 divided by 400 is equal to 0.9p per gram. 0.9 pence per gram of cheese. Now, we know we need to make 2,750, so we do 2,750 times 0.9 pence, which will equal 2475p, which is divided by 100, 24.75. That's how much it costs to make 50 pasties. Okay, another sort of wordy question here, whether I can get all of that all in one go. So 4 bakers can decorate 100 cakes. 100 cakes in 5 hours. How long would it take ten bakers let's go on, to decorate 100 cakes? We'll do it with 100 cakes first of all, yeah? Now, what we're going to do here, so you can either scale up this from 4 to 10 and then scale back from 5, because this is inversely proportional, inverse proportion, because the more bakers we have, the less time it takes to decorate the cakes. Or you can go, well, 4 bakers, 5 hours. If there were 1 baker, it would take 4 times as long, wouldn't it? 4 times as long as there was 1 baker. So you can go for 1 baker is 4 times 5, which equals 20 hours. So it would take 1 baker 20 hours to make 100 cakes. Now you're going to put 10 bakers on the job. So you would divide the 20 hours by the 10, which will give you an answer of 2 hours. Yeah. Now, how long, so this is inverse proportion, yeah, how long does it take 11 bakers to do, I'll just put do instead of decorate, 220 cakes. Okay, now how long does it take? We know that one baker takes 20 hours. To do 100 cakes. So what we do 20 hours divided by 100 cakes equals 0.2 hours per cake. And don't bother changing that into minutes, yeah? And so now we've got 220 cakes we're going to make times 0.2, which equals 44 hours. Right, so it take one baker 44 hours to do 220 cakes. Therefore, we're now going to put 11 bakers on the job. So divide that 44 hours by the 11 bakers, and it would take 11 bakers 4 hours to make all those 220 cakes. So that's the wordy type of questions taken. And the other kind, there's more sorts of questions here. There's another inverse proportion. I'll do this one, yeah. So 2 carpenters take 4 hours, and I'll do 6 bookcases. Okay. So how long for 5 carpenters to make 10 bookcases? Right. So what we need to do here is, as I did earlier there, there's many ways to do this, but I always like to see how long it would take one person to make all this. So if it takes 2 people 4 hours to make 6, yeah, so it's going to be twice as long. So the 2 carpenters times the 4 hours means it's 8 hours for one person to make 6 bookcases. Okay, now we're going to find out how long it takes the one carpenter to make one bookcase. So we need the 8 divided by the 6. Now 8 divided by 6 is 4/3, is 1 1/3. It's going to be a recurring. So it takes one carpenter 1.3 recurring hours. That's 1 hour 20 minutes, but we'll leave it at 0.3 recurring. Yeah. Now we've got 5 carpenters. No, we've got 10 bookcases. So if it takes one person 1.3 recurring hours for one bookcase, we're going to go 10 bookcases times 1.3 recurring hours, which equals 13.3 recurring hours. So that's one person to make 10 bookcases, and then times that by 10, just so that I keep all the, careful on the calculator so that you keep all the recurring bits still in there. Now we've got 13.3 recurring hours to make one person to make 10 bookcases, but we've got 5 carpenters on the job. So if we do 13.3 divided by the 5 carpenters, we get 2.6 hours recurring. Now that's 2 2/3, yeah, 2 2/3 1 hour, which is 2 hours 40 minutes. Yeah, so there's the wordy questions. Now let's have a look at what we've got next. Now this is we move up to the level 6 or 7 questions, yeah, and they're not so wordy, but they always follow the same format. Y is directly proportional to X. Okay, Y is 20, X is 5. Question is, what is Y when X is 10? Now, directly proportional. So this will be the Y equals KX formula. Now, what we need to do is we've got the Y, we've got the X, and we need to find the constant, because that's not going to change no matter what the value of X is. It's not going to change. So we rearrange this to find the constant. So Y divided by X equals the constant, which is 20 divided by 5, which equals 4. So the K equals 4. Now, go back to this again. Y equals, now we've got Kx, yeah? And so Y equals 4 times 10, which equals 40. Directly proportional. So we do an inverse proportion now. Y is inverse. Now, these are all much the same. As long as you remember the inversely proportional to X squared. Okay. So what we've got now, we need to remember the inverse proportional, which is xy equals k, but this time it's x squared. So x squared x squared y equals k. Okay, so that's what we need to remember. So information to get us going is y equals 100 and x equals 5. What is y when x equals 20? Okay, so let's bring that down. So we know what y is, we know what x is. So we've got 5 squared times 100, and we have to work out the constant. So 5 5s are 25 times 100, which equal 2500. That is k. Okay, now go back to this again. X squared y equals k, and we're going to find out what y is. So rearrange this. Y equals k over x squared, which equals k is 2500 divided by x squared. This is 20 squared, so 20 squared equals 400 divided by 400, and that comes out as 6.25. It's the new value of y when x is 5. So you got inverse and yeah. So let's do an object is accelerating, accelerating, yeah, accelerating at 105 meters per second. Okay, after 5 seconds. Oh no, that's all one sentence, isn't it? Right. So after 5 seconds. So meters per second means it's increasing. The acceleration is increasing. So you're going to have this. You're going to have the velocity. There's a speed and the time here. So it must be something that when it started and then it's going woo, yeah, something like this. So after 105 and 5 seconds. So that point is doing 105 after 5 seconds. So we need to be how fast will it be going at 13 seconds? So this is very easy, this one, because we've only got two numbers to play with. So you go 105 divided by 5. So you're dividing this up, yeah, which is 21, and then you go 21 times 13. So it will be accelerating at 273 meters per second. Last one up. G is inversely proportional to the square root of h. Okay? G equals 2, h equals 16. What is G when h equals 36? So let's move that up a little bit for us. Okay, so we need the inversely proportional thing. Inversely proportional. This is the x, y equals k one, inversely proportional. So we've now got to change the x and y to be g and h. So we've got g times the square root of h equals k. So let's find out what the constant is with these two numbers here, 2 and 16. So we've got 2 times the square root of 16 equals h, which is 2 times 4 equals k, and therefore k equals 8. K equals 8. Now, what is g when h is 36? So we'll write that down again. G square root h equals k. So we need to find out g. So g equals k divided by the square root of h. So let's put some numbers in. K is 8, and the h square root of h is square root of 36, which is equal to 8 divided by 6. I don't know whether they're going to want plus or minus 6, but 8 divided by 6 equals 4 over 3. Yeah. Or if we're going to go square root of 6, we could go plus and minus, yeah, and the square root of 4 over minus 3, yeah, and that's either going to be 1 and a third, or and, yeah, minus 1 and a third. Yeah, about a level 7, something like that. Okay, so there you go. So that is the proportion video.